pencil. So, we worked on a problem similar to these first two the other day, actually finding an inverse. We used the example of, what do we use? Fahrenheit to Celsius, and then we switched that around to make it so that we could solve plugging in Celsius and getting out Fahrenheit, something like that. So for an inverse, essentially all we want to do is solve for the independent variable. So we want what was the input, we want that to be our output. So here we want our output to be x, and our input is going to be like the y, essentially. Okay, so the steps we usually go through to do this, you're going to first rewrite the f of x as a y just to make it look a little bit better. So there's my function. So to find its inverse, first we're going to switch the x and the y. Which again should remind you of a certain type of symmetry that inverses have, line symmetry. And now we're going to solve for y again. And that's pretty much it. So subtract 4, divide by 3. Do I need to go through that in more detail? Okay, so we get y by itself. And remember, when you divide by 3, you have to divide everything by 3. So you could do it individually to the two different terms and get x over 3 minus 4 over 3. That would be fine. That's the same thing. But that's what you get. And then the last thing, we're just going to rename this. And what would I call the inverse of f of x? Do you remember how to write that? Haley? Uh-huh. No, we switch the x and the y and then solve for y. And when we do that, we give the function a new name, so we're going to call it f inverse. So this was f of x originally. So I subtracted 4 and I divided by 3. There's my inverse function. Okay, so again, the idea here is we're switching the output and the input, and then rewriting. Alright, let's try the second one. Any questions there first? Okay, so the second one was called g of x. I'm just going to go ahead and write that as a y, just because it looks better, for no other reason. Okay, so I'm going to rewrite it. And to make this an inverse again, I want to switch my variables. I want to switch my input and my output. So now I'm going to input this value, whatever it is, and I want my output to be this value right here. So usually we call the x the input, right? And y we call that the output. So same thing here. We just want to switch their place in the equation. Now this is my input, that's my output. And so to write it as a function, I just need to solve for y. So what should I do first? Ideas? I don't want to do that first. I could do that. Well, actually, I can't do that first because I have to square it first. But I think there's something a little bit easier we could do with this 1/4. What? I heard stuff. Yeah, I want to multiply both sides. So instead of dividing by a 4th, right, it's multiplied over here. I want to, instead of dividing by 1/4, I want to multiply each side by 4. And that's going to cancel out on this side. But then I want to do the same thing to the other side. And that doesn't have to be the thing that I do first, but it's going to make my life a lot easier if I do that thing first. Likewise, I may not actually want to square this y minus 2. That's going to make my expression more complicated. It's okay, Zoe. It was a good idea. So I'm trying to get the y by itself. I want to get rid of stuff. So how can I get rid of that square? Yeah, square root of both sides. Eventually, yes, but to be able to solve for the y, you would have to factor it, which would give you this back. So it would be, it's not wrong to do it, it's just counterproductive. It makes solving for y harder, because then you have two different y's, right, if you actually square this. Remember, that doesn't give you y squared minus 4. Remember, to square it, you have to FOIL it out. So that's going to give you y squared minus 4y plus 4. And that's going to make it hard to solve for y, because now you have two different y's. So that's why we don't want to do that. So then we take the square root, that cancels out the square, and we're just left with y minus 2 on the right side. Now, one thing I could do to make this a little bit prettier, I don't know what the square root of x is, because I don't know what x is. It's an unknown. But I do know what the square root of 4 is. What's the square root of 4? Yeah, so I could write this as 2 times the square root of x, right? So go ahead and take the square root of 4 if you see it there. And now the 2 wouldn't be under the square root anymore, because you already took the square root of that number. So we can simplify that a little. And one more thing to get y by itself. We just need to add 2. And of course, these aren't going to be like terms on the left-hand side. So that's 2 square root of x plus 2. And that essentially is my function. I just need to rename it. So what should I name this function? What is it the inverse of? Yeah, it's the inverse of the function we originally called g of x. So we're going to call it, and I'm going to flip it around to write it in the normal order that we write these in. It's not necessary. So there's my inverse function right there. So instead of writing it, my output as a y, I'm going to name it more specifically. This is the inverse of this other function, g of x. Okay. So that's finding inverses. We worked on that a little bit last week. And then I was out Friday taking many math tests. I would have rather have been here. That's okay. So I left you with a guest lecturer from YouTube, Patrick JMT, YouTube sensation. So were y'all able to watch that video and follow along pretty well? No? He did go pretty fast, a little faster than I usually go. Maybe that was good for some of you, not good for some of you. So we'll go through this warm-up, and we'll talk about these things again. So he talked about a couple of things that we hadn't talked about yet. One of those things being how you find the inverse of a graph, or points, which remember is just a graph written out. These are points on a graph. And then how we can tell that two functions are actually inverse of each other. So that's another thing that he went over. We'll go over these examples, and then I'll give you some to try. Okay. Now, we may have actually talked about this in class. What kind of symmetry should an inverse have with its original graph? Or should two graphs that are inverses, what kind of symmetry should they have? Here's a hint. Yeah, they should have y equals x symmetry. Remember, that's the type of symmetry we checked for by switching the x and the y. A connection. Okay. So what does that look like on a graph? Well, it looks like y equals x symmetry. So I'm going to go ahead and I'm just going to resketch this here. So my function looks something like, no, that's not my function. This is just my line of symmetry right here. And the line of symmetry is the line y equals x. That's why we call it y equals x symmetry. Okay. So my original function looks something like this. Now, He also talked about how to check to see if a graph actually has an inverse. Would this graph actually have an inverse? No, this one wouldn't. Why not? Yeah, this does not pass the horizontal line test. And we'll see if we can make sense of that in a second. So the horizontal line test, kind of like the vertical line test, you run a horizontal line across it, and it should, at most, touch your graph once. Why? Let's talk about that, just to make sure we're all clear. So if I did flip this graph around the line y equals x, what would it look like? So reflected across this line. Okay, so now this arrow right here, instead of pointing down, it's going to flip across this line and point this way. So I'm going to draw in here. Okay? So there's my arrow flipped across this line. Can we see that? Okay, and instead of having a hump this way, our graph is going to have a hump on the other side of the line y equals x this way. And then instead of having a hump over here, it's going to have a hump over here. So it's reflected, and then it's going to go off this way. Now that's very poorly drawn, because I'm not good at drawing things. But in general, our flipped graph is going to look something like this. Okay. Now, the question here really is, there's my original graph again, without stuff drawn all over it. Is my, if I do this reflection, is this going to give me a function? So is this flipped graph actually a function? No, why not? How do we test to see if a graph is a function? Yeah, the vertical line test. Okay. So why do we check? We would call this, by the way, a little old word for you. We would call this the pre-image, and this the image. So before we flip it, and after we flip it. So how do we know whether or not our graph is going to pass the vertical line test after we flip it? Well, we check the horizontal line test. Okay. And so if I flip that horizontal line across the line y equals x, I'm going to get a vertical line. Can we see that at all? It's kind of hard. Well, you don't even, for this one, you wouldn't even have to draw it. When you check the original. Okay. So just to make this clear, I'm going to trace this original graph on some magical patty paper. So here's my line of symmetry right here. And this is what my function looks like. Now, the nice thing about this magical patty paper is if I flip this piece of paper across this line y equals x. So if I flip it diagonally like this, I can still see through it, and that's going to show me what my, let me do this on a blank background. So there's my original graph. So when I flip it diagonally, that's going to show me what my inverse looks like. Okay? That's going to show me what the reflection looks like. So I want to know, would my reflection pass the vertical line test? So here, obviously, no, right? And so what does that look like on the original graph? It looks like a horizontal line. Okay? So that's the idea. So we're double checking without actually having to draw the inverse graph itself. Would the inverse pass the vertical line test? Okay, so that's what the horizontal line test is. Would the inverse pass the vertical line test? Would it actually be a function? So I'll write that down. So the horizontal line test, all you're doing is asking, would the inverse pass the vertical line test? That's the point of that. Okay. So in summary, what does the graph of the inverse of this function look like? It doesn't, because it doesn't have one. We can still draw the graph, but it's not a function. Okay. That's the end. All right. Let's look at the next one. So in D, instead of being given a graph, we're given a list of points. But of course, points are still, things that are on a graph. So the same thing is going to apply. Now, how do we solve for the inverse on these first two questions? What did we do to actually solve for the inverse? Yeah, you switch the x and the y. And how do you check for y equals x symmetry? You switch the x and the y. How are we going to find the inverse of this list of points? We're going to switch the x and the y. So our points are going to be, so instead of 2, 3, we would have 3, 2. Instead of 7, 8, we would have 8, 7. Instead of 9, 10, we would have the point 10, 9. Okay, so I'm going to call this list of points T inverse. And really, if I wanted to make a list, I should put them in curly brackets, because that's how you list stuff in math. Okay, so same thing. Alright, so again, for inverses, if you can only remember one thing, remember switch the x and the y, and you'll be halfway there. Alright. Now we've got number 2. So here we have a different question. This time, we're going to look at a couple of functions and ask, hey, are these functions inverses of each other? Are they inverses of each other? I don't know. Does anybody remember how to find out? There are some of the same numbers. That's a good sign. If they had different numbers, that would be a bad sign. But just because they have the same numbers doesn't mean they're necessarily inverses. Okay, so here's what we do. This is how we check to see if two functions are inverses. We do a function, what's this called? Yeah, composition. Maybe this jogs your memory from Friday. When you do the function composition, you should get the same thing both times, and it's a very specific thing that you should get. Do you remember? Let's think about this. So let's say I have a function, and I input an x, and it outputs a y. Okay? I call that function, let's say, f of x. What does the inverse do? Well, it takes the input, the y, and it gives you back the original thing, the x. So for function composition, I perform both of those functions. So what should my final output be? What should be the same as my original input? So I'm doing something to my x value, and then I'm undoing it. What do I get back? I just get back my original x value. So I get back whatever I put in. Okay? So for instance, if I said, hey, it's 72 degrees outside, I'm going to convert that to Celsius. Okay, fine. Now, you know what? I'm going to take that number, I'm going to convert it back to Fahrenheit just for fun. What am I going to get? I should get 72 degrees, right? So I'm getting back my original function. Or my original x value, my original input. So what this is saying is, if I perform both of these functions, I just get back where I started. That's how I know they're inverses of each other. Remember, doing the composition means we're evaluating both of these functions, one and then the other. So this is how we check for inverses, and we have to check them both. Because every once in a while, one of them will work and the other one doesn't. So this is how we check for inverses. So let's try f of g of x. Oops. For these two functions. So first I'm going to check the fog. Okay. Or in other words, f of, so g of x would be my inside function. So I'm plugging g of x into f of x. And what I want to see is, do I get just simply x when I do that? So help me get started here. Here's f of x, here's g of x. So I'm going to plug g of x into f of x, specifically where the x is. Or in other words, I'm going to do f of, and I'm going to replace g of x. I'm going to replace x with g of x. So this whole thing. So that's a cube root. Then on the inside we've got 3 over 4 pi, and then we have x. Okay? That's what I'm going to use for my input. So when I plug that into the function f, where does that go? Do I multiply by it? No, yeah, I replace the x with all of this stuff. So I'm replacing the x. So I'm still going to have everything else that's in the function. The only thing I'm not going to have is the x. So I'm leaving a blank where my x was. In that blank, I'm going to put all of this stuff. And maybe it looks really bad. Let's see if it works out nicely. Okay. So is this x? Well, it doesn't look like just x yet. Let's see what we can figure out. So the first thing you might notice, I've got a lot of stuff going on over here on the right-hand side. I've got something cubed. I also have something under a cube root. Any ideas what's going to happen there, Casey? Yeah, they just cancel. Hey, that's going to help out. So the cube root and the cube cancel each other out. They're inverses of each other, in other words. So now I'm just left with 4 pi over 3. That part didn't change. And now I'm going to write this other part without a cube root. So 3. Because it was cubed in the original in f of x. So when we plug all this stuff in for x, we replace the x, it's still going to be cubed. So all that stuff that we plugged in will still be cubed. Which is nice because it canceled out that cube root. And we're left with 3 over 4 pi x without all the roots and exponents. So far it's going well. So is there anything else we could simplify here? So I've got this times that times that. What if I just multiply these two fractions together first? 4 pi over 3 times 3 over 4 pi. What's that going to give me? Yeah, it gives me 1. And if you're not sure, you can multiply it out and get 12 pi over 12 pi. Okay, yeah, so that's just going to be 1. So what am I left with? Yeah, 1 times x, or just x. Is that good or bad? That is good. That's what I'm supposed to get if the two functions are inverses. Okay, so that's how I check. Are the functions inverses? Well, let's put them together and see. Do they cancel each other out? And so as we go through here, you notice all of the individual operations are inverses of each other. So cubing something and taking a cube root, those are inverses. Multiplying by 4 pi over 3 and multiplying by 3 over 4 pi, those are inverses of each other. So all the individual operations cancel out because they're inverses. But we're not done. We have to try this the other way too. We have to do g of f of x to be sure. Because sometimes one direction will work and one won't. So let's see if this works the other direction. So this time we're going to try g of f of x. Or, in other words, g of f of x. I like to write it this way first. And what is f of x? Well, it's this big mess over here. So in other words, I'm going to replace the f of x with this actual expression, 4 pi over 3 times x cubed. Parentheses optional there. And where am I going to put this big mess of information? I'm going to put it into the function g, where more specifically I'm going to put it right there, right where the x is. X marks the spot. That's where I'm going to put all this stuff. That's my buried treasure. I'm going to bury it right there. Okay. When I'm done admiring my own jokes, let's try this. So, g of x is the cube root of 3 over 4 pi times all this stuff. So instead of an x, I'm going to put in everything that's inside these parentheses here. So 4 pi over 3 times x cubed. And now we're just going to see what happens. Does that equal x? Maybe. Doesn't look like it yet, does it? What should we do first? Cube what? I'm just going to cube it. I would like to get rid of the cube root, but I can't just cube everything, because that just changes, that's going to change the value of it. So back here, we already had a cube and a cube root written there, right? So they were already there, we just canceled them out. Can we do that same thing here? Not yet. Hopefully later. There's something we've got to do first, because we don't have this entire thing raised to the third power, right? First, let's take care of what's inside this cube root. So what about 3 over 4 pi times 4 pi over 3? Yeah, still going to be 1, just like it was last time. It's 12 pi over 12 pi. So what am I left with? The cube root of 1 times x cubed. Now what should I do, Savannah? Well, it's already cubed. Yeah. So now I just cancel out what's already there. A cube root and a cube, and what am I left with? X. And is that good or bad? It's good, if you were hoping that the answer was yes, they are inverses. If you were hoping that they weren't inverses, then it's bad. Okay, so therefore, and I can answer this a couple of different ways. I can say that f of x is the inverse of g, and g of x is the inverse of f. So it's important that I actually give an answer when I'm asked a question. I guess you could just say yes, but make sure you, if I ask you a question, make sure you actually answer it. So in other words, yes, they are inverses. Okay, we'll practice a little bit more tomorrow. A quick word about those tests that I passed back. There are 2 different sections on that one paper that I gave you. You can retake those sections individually, but remember there's some stuff you got to do first. First off, you have to actually correct that part of the test. Then you have to have any homework assignments that are from those sections. So if it's 2C, D, E, F, like the second part of the test, then go back. I don't think they all had homework, but look at the homework for 2C, 2D, 2E, 2F.
stand for the moment of silence and the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible.
Good morning, Dyer. I'm Spooky Maz.
And I'm Spooky Peyton.
Here with your spooky morning announcement.
Our annual canned food drive will end on Tuesday, October 25th. The Student Council reaches their goal of collecting 5,000 cans for the Salvation Army. Student Council will donate 2 microwaves to the Commons for student use. Let's show the community what the Wildcat family is capable of.
This week is Red Ribbon Week. Join Student Council for the following dress-up days. Tuesday, team up against drugs and wear your favorite sports jersey. On Wednesday, Wildcats don't go wild on drugs. Dress animal or safari team. Thursday, you have the power to be drug-free. Dress as your favorite superhero. And Friday, I'm proud to be drug-free. Wear red, white, and blue.
UNICEF Club members doing trick-or-treat for camp tomorrow. Please come by room B212 today and pick up your permission slip and bring it tomorrow. Thanks.
There will be a Students Against Destructive Decisions meeting next Wednesday, the 26th at 8:15 in B222, Ms. Wallet's room.
Attention class of 2017. There will be senior class shirts sold for the next few Fridays during all lectures. The cost is $15. All profits go towards the grad night party, so support this fun night and show your senior pride. Look for the table set up on the cafeteria on Friday.
The Fellowship of Christian Athletes meets on Tuesdays at 8 a.m. in H151. Please come join us for donuts and a message of hope every Tuesday.
Don't know if you've heard, but Geyer has a new guys volleyball club. We meet every Tuesday morning at 7:30 in the middle gym. Be there.
If you are absent to any class, you must bring a note to the attendance office within 72 hours of returning.
Don't forget to validate with the principals at lunch today, October 24th, and tomorrow, October 25th, for grades. If you qualify with gold, which is all A's, you can go to off-campus lunch on Friday, October 28th. Remember, you have to validate with the principals and turn in the form to the office to be approved to go to the lunch.
Seniors, are you planning to apply to Texas A&M? If so, join Chris Hilario, your A&M rep for Benton ISD, on Thursday, October 27th at 6:30 p.m. at Geyer, as he leads a workshop dedicated to helping you and your parents through the application process for Texas A&M University. Attendees will learn about the admissions process and receive information about scholarships and financial aid. And that's all we have for you today, Geyer. Have a magical Monday.
All right, remember, short version of this, if you forgot, or didn't write it down, it's supposed to be after lunch. It's all for the input variable.